Hello. So I'm going to step you through a basic architecture and then a demonstration of the Leostream connection broker used to manage a classroom environment. So students who are members of certain classes and just making sure that they have access to the correct resources, whether they're on campus or logging in from their home. What you see here is a high-level Leostream architecture. The Leostream platform consists of four components. The first over here on the right is the Leostream connection broker. It's the main brains of the operation. It's where you're going to build your pools and define the policies that indicate which students have access to the different pools in your environment. The broker itself is very simple to install. Installs on CentOS or RHEL, can be on your campus, can be up in the cloud, just about anywhere you want to host it. And the nice thing about it installing on CentOS or RHEL is that that means you don't have to actually invest in a Windows Server license to install Leostream in your environment. The broker communicates with a Leostream agent, which sits on the hosted machines that you need to provide access to. The Leostream agent installs on Windows, Linux, or Mac OS, so you can provide access to whatever you happen to have in your environment, be that a physical machine, a virtual machine, or even if you want to burst into the cloud. The agent is a small component, but it is very important in your Leostream environment. It's providing information to the connection broker about the user's session. Things like, when did they log in? Has the user logged out? Did they go idle? And then you can automate actions based on those events. So those are the two main components that would live on your campus or be in the cloud if you want to host up there as well. There are two other components to the platform. The other major component when you're talking about remote access is the Leostream gateway you see here in the middle. The gateway installs on a separate CentOS or RHEL machine, and it is the publicly facing IP address for your students who are working remotely. The gateway has two functions. One, it acts as a way to proxy in the login traffic from your students who are sitting at home to the connection broker, which is tucked away inside of your data center. After the login completes and the broker determines what the student has access to connect to, the gateway then switches functionality and acts as the tunnel to get your users connected from their client device over to the machine that the broker has indicated they have permission to connect to. The nice thing is by using the Leostream gateway in your environment is it removes the need for you to manage any kind of enterprise NAT gateway. And it also removes the need for a VPN. And what we've noticed is that VPNs can sometimes be performance bottlenecks in larger environments. Obviously, the last piece of the puzzle is the user themselves and the device that they're sitting down at. Now, when your students log in, they can log into Leostream using any number of different client device types. That can be a Mac, Linux, Windows OS. It can even be a Chromebook or an iOS device, any kind of tablet. Essentially, any client with a web browser works just great. We also provide Leostream Connect, which is our software client, installs on all those operating systems I mentioned. And then specifically, if you want to use PC over IP for the connection, the user can use any of the Teradici clients that are out there. So those are the high-level pieces of the Leostream architecture. Now let's look at the connection broker itself. The web interface you see here is the main login interface for your Leostream environment, whether you're an administrator or actually for a student logging in. This is completely customizable. You can change your logos, change the colors, rename the prompts, do whatever you want for it. Now I'm going to log in as the main connection broker administrator. What your students and end users would see is going to look entirely different, and we'll show that later. For now, when I log in as the main administrator, the way this is set up is essentially just menus down the left. And what I always say is start and setup and work your way down. In the setup section, you're going to connect Leostream up to all the other bits and pieces in your hosted desktop infrastructure. The first thing you want to think about is authentication. How am I going to indicate which users and students have permission to log into my environment? By and large, we see many schools use Active Directory, and you can have as many Active Directory servers registered with your connection broker as you need. So if you have individual labs that have unique Active Directory servers, you can manage all of that from a single connection broker here. If you are using any other type of LDAP server, I've seen someone using Oracle LDAP. As long as it works with the LDAP protocol, then Leostream can use that for authentication as well. In addition to older NIS environments, so if you have some older Linux out there, Leostream can manage that as an authentication server as well. Now you do see SAML here. One option that you can do is actually allow any SAML-based identity provider to act as the front end for Leostream. So in this case, your students would actually use your SAML IDP, such as Microsoft ADFS, or I've even seen someone do this with Okta, but they would authenticate with that provider, and then that provider redirects them into Leostream. And that works great for web browser logins to your Leostream environment. Now, if you don't want to use a SAML-based IDP for MFA, there are some options built directly into Leostream itself to provide MFA. And multi-factor authentication, we've seen, becomes a very important topic once your students move off of campus. Oftentimes, anyone who's logging in on-site, well, they can log in with plain username and password, and that's great. But once the user or student moves away, you want to require that second level of authentication to really lock down your environment. The options you have in Leostream for providing MFA, well, there's two main ones. One, we do have native integration with Duo. So that allows users to log in through the web browser. First, they'll use their username and password, and then Leostream will pass the user over to Duo for either a push notification or a one-time PIN, or however you happen to have your Duo environment set up. The broker can also act as a radius client. So essentially any identity provider like Okta, Duo, Ping ID, just to name a few, as long as that identity provider can communicate using radius, then you can use that as for the second level of authentication as well. Now, currently our radius integration is set up to require the student to type in the one-time token. So for example, I have Okta Verify on my phone, and Okta Verify sends me a six-digit PIN, and I type that in. We are in the process of adding push notifications for that, so that should be coming shortly. The one thing I will point out, our radius integration does give you the widest range of support for different client types. So web browsers, PC over IP, Leostream Connect, radius is available for all of those, while the Duo and the SAML is specific to web browser logins. So after you determine how you want to authenticate your students, next thing you need to do is tell Leostream what are all the machines that you want to manage access to. Now, what we've seen a lot right now is that schools and universities have classrooms and labs full of physical devices that they need to be able to manage both an on-prem and an off-prem student-based connections to. In that case, what you do is you install our Leostream agent on the machine, again, Windows, Linux, Mac, whatever you have, and the agent enrolls the desktop in the Enroll Desktop Center. Essentially, a center is a bucket to inventory all of the different resources you want Leostream to be managing. Now here you notice for my Enrolled Desktop Center, over here, I have an assign rogue user policy set. If you think about it, if I have a lab full of desktops, when a student wanders in there, they're just going to sit down at that machine and log in directly to the console. Well, how do you manage remote users not also trying to connect to that machine? That's what you can use this rogue user assignment action for. When the student logs into the desktop console directly from the lab, the Leostream agent is still going to send a login notification to the connection broker. And Leostream is going to look at that login and say, oh, hey, you know what? This user's rogue. They didn't first log into Leostream. They just connected directly to the desktop. And now by assigning that rogue user to a policy, that means, well, I still want to manage that rogue user as if they logged in through Leostream in the first place. And so Leostream takes over that session so that you can manage the length of time that that user is assigned to that machine, perform some power controls, and do some other actions that you'll see later in the demo. The key is that once that on-prem rogue, quote unquote, user becomes a Leostream user, now your connection broker knows not to offer that machine out to any of your users who are logging in remotely. So now you can have people on-prem and off-prem and make sure there's no conflicts in resource usage. And that obviously that option applies not just to physical machines, but to any machine that you have in any center. Speaking of any centers, you'll see that in my particular broker here, I am managing a hybrid environment. I also have a VMware center here, so I can manage any kind of virtual machines hosted in VMware. And then we've also hooked this broker up to the cloud, Google Cloud Platform, Azure, and AWS. Leostream does integrate with all of those different cloud platforms. And we leverage the native cloud APIs so that you can manage power state and also capacity in those clouds. And the whole idea there is to be able to burst your students up into the cloud while helping you maintain your cloud compute costs. Every time you create a center, essentially as soon as you save that form, Leostream calls the APIs for that center and inventories everything that you have there already. The desktops page here shows you all the list of desktops. And so as an example, I have one machine up here running in Google Cloud Platform. Now this page becomes very important when students start logging in and utilizing resources because you'll see their name appear here in the assigned user column. And that way you always know who's using what. And if you need to, you can click status to query the Leostream agent, see that the user is logged in, and actually even forcibly log them out. The Images tab, this shows you any master images that you have in the cloud or the virtualization platforms that you can use for automating provisioning and expanding and contracting capacity in that cloud. The last bit in the setup here that I'll mention is on the gateways page. If you want to use gateways with your broker so that you can have the VPN-less remote access for your students, after you install the gateway, there's very little configuration that you'll do on the machine itself. For the most part, all you need to do is come in here and add the gateway to the connection broker. Indicate the publicly facing address that the student will use to connect to that gateway. And then if you want, if the broker shouldn't be talking to the public IP, if the gateway also has a private IP, you can set that as well. Now you can have as many gateways here as you need to satisfy your network architecture and your student base. So if you have different desktops in different networks, you can have a gateway for each of those networks. Or if you have a very large number of students who are remoting into your campus, you can have a large number of gateways and create what we call a gateway cluster so that a load balancer would distribute load around those gateways. So that's the idea in setup, is to just hook us up to all the external systems that you have. And ideally, once we're all hooked up, you can leave that section alone and move into here and do the configuration. Here's where you're going to define all the pools and policies that indicate which students have access to the different desktops in your environment. You're going to start by creating pools. Now, pooling in Leostream is extremely flexible. And the whole thing that you should be thinking about is how should you create your pools so that you can manage those desktops and also offer them out to the students who need access. As an example, here I have a pool, which is everything I'm considering to be in my cloud lab. So I have a naming convention here. GCP is standing for Google Cloud Platform, and I've created a pool, which is everything in that machine. And I've done that because in my environment, I'm saying I have one admin who needs to manage everything up in that cloud and in that lab. Now you see this pool also is dynamic. It's managing the capacity that's up in Google Cloud Platform. And I've done that by enabling provisioning. Now there's two ways that Leostream can provision resources up in the cloud. One is just ahead of time. So here I have one machine that's available and waiting for this first student to log into that pool. When a student logs in and grabs that machine is going to move from the available slot into the assigned slot, which is going to make my number of available go to 0 and will trigger my lower bound on my provisioning. And I can always create a cap on my provisioning so that I don't over provision in the cloud. Again, it's about keeping your costs in check. So there's this idea of static limits. But then what if you have a classroom that you actually want to schedule up in the cloud? Well, in that case, you know more about when that class is running, so you can enforce the provisioning limits based on time of day. So I can indicate the day the class is running, provide a start and a stop time, and then set thresholds for that period of time, and otherwise keep the pool nominally at 0, again, so I don't have any compute in the cloud that I'm paying for when I don't need it. So here in the provisioning limits section, I tell the broker when to provision machines, and then the provisioning parameters tell us how. And what you'll see here in the provisioning parameters section all depends on the platform into which you're provisioning. So for Google Cloud, obviously I set my machine name template. I indicate the master image that I want to use and then provide the zone and the machine type. Now for the cloud specifically, if you do want to terminate machines when the user is done with them, then you can mark the desktop as deletable here. So the broker knows it has permission to delete that machine. And then later in release plans, we'll show you when that deletion occurs. So in my pooling setup here, in addition to having my dynamic cloud lab set up, I've also created some pools that are my classrooms, the physical machines that are sitting in the different rooms. For example, I have one room that's considered for French 3 and another one for Math 202. And how you configure those completely up to you. You can use desktop attributes like their IP address. Perhaps you've got a naming convention. Again, it's very flexible. So just as long as the correct machines show up in the pool based on what you have. These are the pools, the French pool and the math pool I'm going to offer out to students in addition to that cloud lab. Now, once you have your pool set up, the next thing to think about is how do I want to manage the desktop connections to those pools? The first thing you need to do is indicate how am I connecting the users. Leostream does support a wide range of display protocols, so anything from RDP and VNC, even some SSH, all the way up to the high performance display protocols that your engineering or CAD students might need. So PC over IP, HP Remote Boost, MEC9 TGX, PC over IP, you see many of them there. Again, the key is create as many protocol plans based on how you need to connect the user. As an example, here you notice this form's broken into sections, Leostream Connect, web browsers, those are those device types that I mentioned that the user logs into. And then based on the device type, you indicate what protocol you want to use. Here, for example, I'm using the Leostream HTML5 viewer. The HTML5 viewer is built into the Leostream gateway. It can do RDP, VNC, and SSH, so works great for any operating system you happen to have. You can also use any number of what I call client-based protocols. So essentially, if you think in this case, I'm saying Leostream Connect is just going to launch RDP connection. On Windows, this launches MSTSC with the configuration set up in the configuration file. So here is where you'd indicate, is this full screen? Can the student redirect their local printers? Things like that. So create as many protocol plans as you need. Now, the nice thing here is here you see I have a protocol plan that uses no machine and another one that sends that no machine connection through our Leostream gateway. So by decoupling the broker and the gateway functionality, I can send students who log in from home through the gateway, but I don't have to do that if they're logging in directly out on campus. So protocol plans tell us how to connect the user. Power control and release plans, here's where you start to see the Leostream agent come into play. As an example, notice this form is broken into sections. Did the user disconnect? Have they logged out? Did they go idle? Those are those notifications coming from the Leostream agent. So here, what I'm saying is, well, when the desktop is released, reboot the machine. I've been told that Avid, for example, really likes to be rebooted after it's been used, and that way the next user who logs in to uses it has a nice clean session. So you can automate those types of processes here, or simply shut down machines, for example, in the cloud. Now I mentioned disconnect, logout, and idle comes from the agent. Where's this release come from? The release is when that assignment I mentioned is broken, is released. And that event is triggered by your release plans. Release plans indicate after the user gets first assigned to the machine, how long do they own it? And that's key because as long as that user owns that machine, the broker always offers it to them when they log in and won't offer it to anybody else. That's how you prevent these conflicts between on and off-prem campus or on and off-campus students. As an example, let's look at the cloud lab. Again, you notice it's broken into these sections: disconnect, log out, idle. Now, the thing about these events is they can trigger one another. So here I'm saying if the user disconnects from the session, so I close my RDP window, but I didn't log out of the remote operating system, that is a disconnect. And I'm going to give them 30 minutes to log back in. If they don't, well, that triggers this release event. And that release event will trigger this section of the plan down here, which says, go ahead and delete the machine. This plan also looks at idle time. So it's saying, well, if the user's idle after 15 minutes, disconnect the machine. This is a security thing. You don't want students sitting there with sessions open. So I'll disconnect it after 15 minutes, and then they have another 30 minutes up here to reconnect. And then if they don't, well, that machine goes away again. So create as many release plans based on the type, again, of workflows you have. Maybe you need to give users access to a machine for 4 hours. You can create a plan that does that. Here I just manage on versus off-campus users separately. Now all of this, the pools and the plans, come together in what we call policies. Here is where you're going to indicate which pool do the users have access to. So let me just look, for example, at my off-campus plan. Now, these policies can be very long sets of rules, but the key is that here they're going to offer some number of machines. In this case, I'm offering one machine from my Math 202 pool. Now, should that pool become empty, essentially, let's say there's 20 machines in the room and 20 students walked into it. Probably not going to happen these days, but you never know. If that happens and all the machines get assigned out, I'll fail the user over up into the cloud. So basically, I'm going to have some extra capacity there up in the cloud for the users just in case. Now, what I want to say is maybe not every user of this policy gets offered this pool. Here I'm actually further filtering it so that this pool is only offered to users who are a member of the Math 202 group. So I've modified my Active Directory and assigned users and students to groups based on my classes. And then down here, I've assigned the different protocol, power control, and release plans both to my main and my backup pool. Now, a policy can offer machines from multiple pools. So here I'm also going to offer one machine from my French 3 pool to anyone in French 3. And then finally, one machine that happens to be a Mac from my engineering pool. And you notice because the protocol is set at the pool level inside the policy, I can change the protocol, I can change the release plan based on that pool as well. Now, before we talk about getting this policy assigned out to users, let's look at locations. A location is essentially a group of clients, kind of similar to how a pool is a group of desktops. But what this allows me to do by setting locations is change what the user has access to or how I connect them based on where they log in. So here I've created a subset of everyone logging in from a Leostream Connect client. And then below that, I know that my on-prem IP address range is in the 10.1.10 network, so I've set a location that's everyone that's on campus. And that way I know the off-campus, anyone not in that range is logging in from off-campus, and I can make sure to direct those connections through the gateway while setting on-campus users not to go through the gateway. The last bit before we talk about assigning policies is roles. For end users, roles don't have too much functionality. It allows you to indicate if they're allowed to reboot their own machine, for example. But what it's really useful for is providing role-based access to this entire web interface. So I mentioned I have that Cloud Lab pool. This is a role that locks down this interface so that when the user logs in, they have no access to every page except for the desktops page, but only looking at the Cloud Lab and only for certain functionality. So they're allowed to perform power control and look at the status, but maybe not up, maybe I don't want them to upgrade the agent, things like that. Now this all finally comes together in what we call assignments. Now if you see here, I have 2 rows. Those are the exact 2 rows that you defined here in authentication servers. And in here in the assignments table, I'm finally going to indicate how are these policies getting offered out to students. And what I'm doing is I'm saying, well, for my Cloud Lab administrators, they're in a group engineering instructors. And so when that group of users logs in from a web browser, they're going to get that lab administrator role. And they don't need a policy. Policies are strictly for end users. But now for my students, anyone who happens to be a student, if they're logging in on campus, they're going to get the on-campus policy. And if they're not logging in on campus, then they're going to get the off-campus policy. Now remember, they're a student and that will assign them to a policy. And then in the policy, it's filtering the different pools based on their class. If somebody falls through all these rows, they come down here to the default. And in the default, I'm blocking login. So this gives you a way to indicate that only people or students or instructors that you've specifically put in your groups can log into your Leostream environment and access your resources. Now, before users and students start even logging in, you can come here to the users page and test this out. So here, let's give a test for Laura. And let's say she's logging in from a web browser. So this simulates the user login. So here at the top, I see my test parameters. It tells me it found Laura in my Active Directory server. And then you come down here and you see the broker stepping through the assignment rules. She's not an instructor, so she didn't match that row. She is a student and happened to be logging in from an on-campus client, so she matches that row. Here's her role and policy, and then you start to see the policy logic. So when it comes to the math pool, well, she is in the math group, so she's going to get that pool. She is also in French, so she's going to get access to that pool, but she's not in the engineering class, so she's not going to have access to that pool. I can see this in action here. So here, if I log in now as a user, as a student, what they see is different. So here she sees access to her new machines, and I can come in here and connect. And in this case, it's launching the HTML5 browser inside of the browser here. What you see as that's going on the system log page, you have a running tally of everything that's going on in your system. So here I see Laura logging in. I see the machines that she's going to be offered. And the interesting thing, you'll notice this tells me the machine, the exact machine she was being offered, even though I displayed it to her just using the pool name. So they don't need to know, they just need to connect. She logged in and that made her assigned to it. And then you start to see the Leostream agent notifications there as well. Now, if I look over here on the desktops page and filter back on the French pool, I can see her username show up here, and I can query the Leostream agent to see, yep, she is logged in. And if I want, I can even come in here and forcefully kick her out. Now, let's look at Leostream Connect. This is our software client. It is also brandable. You could take our logo out, put your own in. Now what I'm doing is I'm going to log in as a person who actually is assigned to that cloud lab. So here you can see I'm being connected to the Google Cloud Platform machine. And if I look at the system log page now, let's move that out of the way, you see what happened. I requested the connection to that machine. And now because I got assigned to that machine, that triggered my provisioning limits, and it's spinning up a new machine here, which I can see happen if I refresh there it is, if I refresh my page here. So now that new machine is there for the next user. Now Bill, he actually has that Cloud Lab role, sorry. So now if he logs into the web browser, notice how different this menu looks, and now you can see he actually sees the different machines, the IP addresses, who's assigned, their power status, can come in here and reboot them if needed and perform actions such as that. The last connection I'll show you is for the Leostream user. In this case, this person's actually assigned to a Mac. So again, any operating system you want. This is actually a connection to a physical Mac Mini. That's my Google Chrome or my Google Cloud Platform desktop opening in the background there. And then here is the no machine connection to the Mac that's being established. And again, you see all of this happening through the system log page. And that's essentially the demo. If you'd like to learn more, feel free to reach out to us.